Hey everybody, it's Mr. Conan here, and today we're going to be talking about the discriminant. So, the discriminant can be written as b squared minus 4 times a times c, where our a, b, and c come from our standard quadratic form y equals a times x squared plus b times x plus c. Now, the discriminant tells us exactly how many points we are going to be dealing with, how many solutions we're going to be dealing with. So, let's run through an example. Here I have y equals x squared plus 4x plus 3. Now, the first thing I'm going to do is find out my a, b, and c values for this equation. When we don't see a number in front of our x squared, we know that there's an implied 1, so my a value is going to be 1. When we look in front of my x, we have a 4, so my b value is going to be 4. Finally, I'm going to look at the last term. I have a 3, so that tells me my c is going to be 3. Now, I'm going to write out my discriminant formula. I have discriminant equals b squared minus 4 times a times c. So I'm going to start plugging in these values. Now, the first one I'm going to have is my b squared, so I have 4 squared minus 4 times my a, which is 1, and my c, which is 3. Now, when I simplify this out, 4 squared is going to give me 16. And now I'm going to look at this whole term, 4 times times 1 times 3, which gives me 12. So I have 16 minus 12. Which gives me my discriminant of 4. Alright, so moving right along. Next example, I have y equals x squared plus 8x plus 16. Again, the first thing I'm going to do is find my a, b, and c values. Now again, we don't see a number in front of our x squared, so we know that there's a 1 there, meaning my a is 1. Looking in front of the x, I have an 8, so my b value is 8. Finally, looking at my last value, I have 16, making my c value my 16. So, I'm going to write out the discriminant formula again and start plugging in numbers. So, starting off with b squared, I'm going to have 8 squared minus 4 times my a value, which is 1, and my c value, which is 16. Now, I'm going to simplify this all together. So, I have 8 times 8, which is 64, minus 4 times 1 times 16, which is 64. 64 minus 64 gives me 0. Example number 3, I have y equals 2x squared plus 6x plus 8. Again, I'm going to start out by finding my a, b, and c value. The number in front of my x squared is 2, so my a value is 2. The number in front of my x is 6, making my b value 6. And the number alone is 8, making my c value 8. So, plugging in my discriminant formula, b squared minus 4 times a times c. I have 6 squared, my b value squared, minus 4 times my a, which is 2, times my c, which is 8. Simplifying this, I have 6 times 6, which is 36, minus 4 times 2 times 8, which gives me 64, making my discriminant 36 minus 64, or negative 28. Now, what the discriminant tells us is exactly how many real roots we're going to have for our equation. So, when the discriminant is positive in a perfect square, like in the first example, I know that the 4 was positive and 4 is a perfect square because 2 times 2 is 4. I'm going to have 2 real rational solutions, meaning I can represent my solutions as either a whole number or a fraction. When the discriminant is positive in a non-perfect square, what that means is a number that you can't take the square root of to get a whole number. We're going to have 2 real irrational solutions, meaning we can represent these numbers by a decimal, that we can't represent it by a fraction. When the discriminant equals 0, we're going to just have 1 real solution. This means that if we were to solve out this equation, there would be 2 roots, but they would both be the same number, meaning there was 1 real solution. Finally, when the discriminant is negative, what that tells us is that we're going to have no real solutions or 2 imaginary solutions. And you can remember this by saying that if it's not real, then it's imaginary. So each of these situations is going to have 2 roots. Whether they're going to be real or going to be the same depends on what the discriminant equals. If you have any questions, feel free to ask. My email is nconine@smcm.edu. Thank you and have a great day.